So what is induction heating? Induction heating is an accurate, fast, repeatable, efficient, non-contact technique for heating metals or any other electrically conductive material. Simply to say, if you all remember your childhood days and you would have some point in time played with a magnet, it's just like a magnet. So if you had a magnet in your hand, as long as there was no metal around it, yeah, we are recording the webinar. In case somebody leaves in between or the networks are not good, I will share the link at the end of it, so it's beneficial to all. Now, coming back to it, if you had a magnet and you put it on a paper, you would see no reaction. Similarly, an induction is the same case. And if you put a metal through it, only the metal gets impacted. Conductive metal, rest has no impact of induction. So it has to be an electrically conductive material. Let's dig into the history of induction heating. Michael Faraday is generally credited with the discovery of the fundamental principles underlying the induction heating. Initially, it was a problem child. Everybody was doing research on induction to find out how to reduce its effects. The effects were causing problems in devices like transformers, motors, generators, where they had a lot of winding of electrical cable on top of a metal, and they were causing other parts to get heated and making the overall process inefficient. So a lot of focus early on in the 1790s and 1830s was largely on the reduction of impact of induction rather than use of it. And then they realized that it has so much power and so much opportunity that they could use it to do many things, including melting metals. So the initial start of induction was in about 1916, where they started use of induction for the possibility of metal melting. Early applications were melting small charges of metal using spark gap oscillators. Spark gap oscillators, most of you would have remembered your age-old radios or transformers, and you could have seen a bulb kind of a device there that was an spark gap oscillator, and vacuum tubes. So they also used induction heating to heat metallic elements from vacuum tubes to drive off or absorbed gases prior to sealing of the vacuum tube. Again, you could heat it with the non-contact from outside, and thereby you could do that without having anything getting inside itself. Today, induction has taken its place in the industry as good as making a speeding part production, reduction in production costs, and achieving very good quality. It has also taken a role in our household impact, and you can very comfortably now see the induction cooktop that most of you use. I have had the privilege of having a look at it way back in the early 80s and early 90s, late 80s and early 90s, where one of the trips my father had the opportunity to pick up one induction cooktop, which was that time used only in hospitals as a quick measure to sterilize tools. So early surgical equipments that were sterilized before the operation, that was the use of the modern induction cooktop that you see today. It all began with Faraday's law. So what was Faraday's law that says, and what does it say? Basically, magnetic flux exists. And in Faraday's experiment, they realized that a steady magnetic flux doesn't do anything. But if you kept changing the magnetic flux, then it had a very positive impact of inducing an electric current on the object. When the magnitude of the induced EMF, electromagnetic force, is proportional to the rate of change of magnetic flux. Now, what this meant was frequency, and what this means is the current induced.